In order to perform the experiment, we have to go to the engineering laboratory to get the equipment and materials needed. First step is to set the towers 1 meter apart and make sure that the receiving antenna is set for horizontal polarization. And then, mount the Yagi boom onto the antenna mount and place a single dipole on it as shown. Make sure to not tighten the screw so it can rotate freely. Make sure to extend the ends of the elements of the dipole so that its length will be 10 cm in total. Using the black cable, plug it into the receiver and generator port of each tower. Using USB, connect the cable into the generator and the computer. And then attach the receiving antenna to the receiving antenna tower. When all hardware connections are done, turn on to the power to the generator and the more enable switch. The generator antenna should move and then stop. Open the SPIL software from the computer and launch the 57200 antenna lab. Choose the dipole in free space, then choose Practical 1. Under it, open the rotor generator controller and then press antenna to 0 function. The generator antenna move and then stop. Align the dipole so that the side of the dipole faces the receiving antenna. Connect the antenna to generator. And then set the value of frequency to 1500 MHz. Open the real-time signal display and check if there's a signal present. The bar represents the strength of the received signal. After that, open the radiation plotter and click Plot. The generator antenna should rotate while plotting. The plot shows the horizontal radiation pattern of the dipole. For the second part, move the dipole to the side of the antenna mount so that the dipole is vertically polarized. Twist the receiving antenna through 90 degrees so that the rods are vertical. Receiving antenna should now be set for horizontal polarization. At the radiation plotter, click Show 90 plane and then click Plot. The generator antenna should rotate while plotting. At the radiation plotter, the 3D controls can be used to rotate the display and shoot both horizontal and vertical plots on its respective axis.
The real-time signal display showed that the horizontal orientation of the dipole antenna transmits a signal level of 44.3 decibels. This was the maximum recorded signal strength. It was observed when the generator antenna was directly facing the receiving antenna and had minimum distance between the towers. The plotter recorded a radiation pattern that resembles a figure 8. The Referring to the plotter showed that the highest signal levels are observable at 2 points. In addition, a minimum signal level is also noticeable at 2 other points in the plot. Observing the rotation of the antenna while plotting reveals that the maximum signal level is observable when the length of the antenna conductor is perpendicular to the direction of the receiving antenna. On the other hand, the minimum signal levels are observable whenever the length of the antenna is parallel to the direction of the receiving antenna. After changing the polarization of the antenna, the plotter recorded a different radiation pattern. The pattern almost resembled a perfect circle. The radiation plotter showed that in the vertical orientation of the antenna, it radiated the signal evenly across all directions. The approximate average of the signal level recorded by the plotter was around 45.7 decibels. The difference of the vertical and horizontal polarization of the dipole antenna is more apparent while using the 3D feature of the radiation plotter. The radiation of the vertical dipole antenna is radiated virtually equal in all directions, while the signals radiated from a horizontal dipole antenna is at maximum in specified directions.
In this practical, the students are expected to utilize a single dipole on an antenna system and to obtain the radiation pattern produced by the antenna that is oriented horizontally and vertically. Using the SPILE software 57200 Antenna Lab and the receiving and generator antenna equipment, radiation pattern plotting can be done. Based on the results discussed from a horizontally oriented dipole, the highest signal level is acquired when the length of the dipole antenna is perpendicular to the direction of the receiving antenna, whereas the signal level is 0 when the length of the dipole antenna is parallel to the direction of the receiving antenna. The radiation pattern is similar to a figure of number 8. Furthermore, when the single dipole is oriented vertically, the radiation pattern displays the signal level in all directions, giving the impression of an almost circular radiation pattern. Therefore, the vertically oriented antenna radiates equally, whereas the horizontal dipole antenna radiates a directed signal. The students conclude that the antenna used for this experiment is a Yagi antenna which acted as a half-wave dipole. This kind of antenna is used particularly where directivity and gain are required. Hence, the Yagi antenna gain allows all the transmitted power to be directed into the area where it is needed, and when used for reception, it allows the maximum signal to be received from the same area. This experiment showed the students how distance, angle of placement, and obstruction between receiving and generating antennas could affect the gain and radiation in wireless transmissions.